Hello everyone, welcome back to this channel. My name is Khushbu and in this particular video I am going to discuss with you about one of the very interesting and important at the same point a topic known as machine learning project pipeline. So in the data science industry, how a machine learning project pipeline gets built or developed, we will be majorly discussing about that. Also, by watching this video, you will be getting an overall understanding about how a data science project in all other fields such as deep learning, NLP, computer vision, how a project pipeline is developed and built. So watch this video till the end to get a complete understanding. Alright, here in this video, I am going to discuss the steps pipeline in which manner we used to build in stepwise manner. Okay, so I'll be writing each point one by one and will be explaining about each one of that. Also, this video is going to be very helpful for fresher to explain in the interview about how a machine learning project pipeline gets built. So the interviewer is going to be very impressed if you are going to explain this pipeline in this way, how I am going to teach you right now. Also, at the same point, if you are an experienced person, so for you also this is going to be helpful. So let's start. The first step in the machine learning project pipeline is data ingestion. This is the first step in any kind of project, like for any domain you would say. So the data ingestion in general means bringing data into your system. If you want, you can make a note of all this what I am teaching to you so that it will be helpful for you to keep a reference for it. So data ingestion simply means that bringing data into your system. You need to collect your data and bring into your system. Now, the source of data can be anything. Means the medium from where you are bringing the data into your system can be anything. You can bring your data from any databases, let it be MongoDB, MySQL or Cassandra. You can bring your data from any cloud storage platform or Hadoop storage platform. It could be anything. Fine. Now, majorly inside the data ingestion phase, what we used to do, bringing data into your system, and again at the same point, we will be splitting our data. We will be splitting our data into train and test. Splitting the data into train and test. Fine. Now, why this splitment is done? That's because when we will be having training data set, we will be performing all kind of feature engineering, EDA, feature selection on top of the training data, and when we will be building our model at the very end, so for testing that model, for knowing that the model that I have built, the model that I have developed, is it predicting correctly or not. So to test our model, this test data is very important, because this test data is a kind of data which is unseen for our training data set, right? So that we will be able to know, we will be able to predict clearly that is my model is predicting correctly or not. So these two things, these two steps is done inside the data ingestion step. Now, let's move to the second step. Second step is data validation. Data validation. Now, this step is again really very important and critical at the same point, because here in this data validation step, we perform various steps inside this. Okay, let's discuss each one of that one by one. Here I am writing the point as a sub point, you can say. Okay, so the first thing that we used to do inside data validation is schema validation. Okay, schema validation. Now, what does it mean by schema validation? Means what actually we use to perform inside this schema validation. So the first thing, the first thing that we used to do inside this schema validation is we will be checking about the file type. We'll be checking about the file type. Now, the second thing that we will be doing inside this schema validation is we will be checking the number of columns. Number of columns. And the third thing that we used to do inside this schema validation is checking the data type of the column that we have. Data type. So these three steps is performed while validating the schema. What are those? Checking the file type. What is the type of your file? Checking the number of columns, that how many number of columns is there in your data set. Also, we will be checking about the data type of the column, like is it categorical, is it numerical, is it of object type. So these things is performed inside the schema validation. Now the next thing that we use to perform inside data validation is checking for the null values. Null check. Okay, here we used to check that in our data set, is there any kind of null values is there or not, or any kind of missing values is there or not. So this null means missing values. Okay, now the third thing that we will be validating inside this data validation is for imbalanced data set. For imbalanced data set. Now, in this imbalanced data set, we used to check that is the data set that we have got is imbalanced or not. Now, if you don't know about what is imbalanced data, let me take one example. Okay, let me take one example to make you understand. For example, I have 1000 data set, 1000 data set you can say of patient. Okay, 1000 data set of patient I have. In that 1000 data set, I have 80 data where 80 data who is a, let's say, cancer patient, and remaining 920 data I have of healthy people. Okay, healthy people. So as you can see here, I have 1000 data set where only 80 people is suffering from cancer. Remaining 920 is healthy people. So here it's not a kind of balanced data set, right? So this is how imbalanced data set look like, and we check for the data that it is imbalanced or not. Now, the fourth thing that we check is for duplicacy. Duplicate data. Okay. In the data set, is there any kind of column which is duplicate or not? Is my data set containing duplicate values or not? So these things is checked in this duplicacy validation. Now after that, we used to check for domain value. Let me write all of the points, and then after I'll make you understand. Now after domain value, we check for data drift, and lastly we check for anomalies. One more thing is there that we can take is for data range. Okay, so in total these all are the steps that we use to validate inside data validation step. Let's discuss the remaining points. So duplicate data we already understood. Here we check for duplicacy of the data. After that, domain value. Now domain value, what does it mean to say? Let's understand this way by taking one example. Okay, by taking one example, it will be easier for you to understand. Okay, so suppose I have a column called as gender. Suppose I have a gender column. So in the gender column, what do you think? What kind of data what kind of data type I can have? I can have only two type of data here in the gender column. That is, either it could be male or either it could be female. There is no such data that we can put inside this gender column. So domain value means that checking the data that it is suitable for a particular column or not. Now here, if I'll be taking any other any other type of data inside this gender column, it won't be validating, right? It won't be like acceptable here in this gender column. So that is what we check inside the domain value, that is it belonging to the same column or not. The data that is even belonging to the same column is of that type or not. This is it mean by checking the domain value. Fine, I hope you understood. Now, the next thing we use to validate is data drift. Now, what does it mean by data drift? Again, this is a very, very important term. Okay, so let us understand this way. So as a machine learning engineer, you will be working on the real data set, right? On the real data set you would be working on. So suppose today you started the project and you got a data set, right? You got a data set. You just perform different kind of statistical analysis on top of your data set. And suppose if you are working on the real data set, the data is going to change in the future, of course, right? The data is going to change in the future. Now let's say after 5 months I again like run my pipeline with the new data. So do you think the analysis that you have done right now and the analysis that you will be doing after 5 months will be similar? Of course not, right? There will be some kind of changes for sure. So that is what this statistical analysis, the difference in the statistical analysis, the unalignment of the data is called as data drift. Okay, non-alignment of the data is called as data drift. Okay, so let me write here, when statistics of old data set is no longer aligned with new data set. Okay, so I hope you understood, because that is why while working on a project it takes around 1 year or 2 years to work on the same project, because every time the data gets changed. So as a consequence of this data drift, whenever the pipeline gets run again, and when we come to a conclusion that there is a kind of difference in the data distribution as compared to the earlier, so in that case we need to again modify our code whatever we have written, because here the total analysis used to get changed. Not total, I can say there will be a kind of variation in the data distribution. That is why we as a data scientist used to work over the same project over an year. Also, suppose if you have written the code in the month of January, now that is not going to work for you in the month of September. That is why whenever we run the pipeline, we need to modify our code whatever we have written. So this is it mean by data drift. Hope you understood. Now the seventh point is anomalies. Anomalies, in simple term, you can understand it as outliers. Okay, outliers. Now if you are not aware about this term outliers, here I'll take an example. Suppose I have a column in the data set uh, where age is given, age column. So in the age, what value you can think could be there, from starting from 1 to max 99 or 100, let's say, right? So suppose in the age column you got any number as 500. So what you will consider is it can it be happen that 500 can be age of some person? No, of course no. So that is why it will be considered as an outlier for the age column, that we considered as an anomalies, and that also we use to validate inside this data validation step. Now, after that, the last validation that we will be doing here is checking the data range. Means the range that we have that should be there for the column, is it in the same range or not? So these all are the steps that we use to perform inside the data validation, which is very, very important to do, because all the other pipeline that we will be talking about or we will be developing is particularly based on this data validation. So we actually need to give time on validating our data and then only move to the next pipeline. Okay, let's move to the next step in this machine learning project pipeline. Okay, so the third step will be here is data transformation. Data transformation. Now here, as the name only suggests, here we will be transforming our data. Now after validating, we need to perform some kind of feature engineering or exploratory data analysis that is called as EDA. That is called as EDA or feature engineering. Okay, feature engineering. Now, this kind of analysis, that is EDA or feature engineering, we actually used to perform in the Jupyter Notebook, because Jupyter Notebook is again very handy. So that is why we used to perform all kind of analysis and also visualization technique on the like on the Jupyter Notebook, and we used to conclude and used to know about about our data set in a much more well-mannered way. Also here we used to perform all other techniques such as one-hot encoding. Also we will be performing, if in case our data set is not scaled, we used to perform standard scaling on our data set. So these kind of transformation is done in this particular data transformation step. Also in the data transformation step, we used to perform various experiments to know which particular algorithm is working very good for my data set, so that we will be having a clear-cut understanding while model training that which particular algorithm is giving me good accuracy, right? So that we will be writing the same particular code like in a script, and we will be deploying later. All right, let's move to the next project pipeline, that is model training. Okay, model training. Also, as the name suggests, here what we will be doing, we will be training our model. We will be training our model. We will be choosing a particular model, that which model is giving me good accuracy, what we did in the data transformation, and we will be selecting that model. So what thing we will be doing here? Model selection. Model selection. Also at the same point, one more thing that we will be performing inside this model training step is hyperparameter tuning. Hyperparameter tuning. So these two steps is performed inside the model training. Alright, and also this model training is done inside the Jupyter Notebook. After training our model, what we will do is we will save a pickle file. Save a pickle file. This pickle is a format of a file where we used to save the model train model. Also one more thing I left over here, that here after doing the EDA or feature engineering step while that data transforming, we will also be saving the pickle file. We'll be saving the pickle file. Now we'll tell you what we will do of these two pickle file, what we are saving here. That is again going to play a very important role later. We will see about that, don't worry. Now that's it for model training. The next step is of the next step is model evaluation. Now, as the name only suggests, that here we will be evaluating our model. Now, at the very first step, what we did is we splitted our data in the train data set and test data set. So that test data is going to play an important role here in the model evaluation, where we will be evaluating our training data with that unseen data, which is nothing but our test data, to evaluate our model, that how good it is performing with on the top of unseen data. So here we will simply evaluate our model, that's it. And after evaluating our model, also one more thing that we will be performing here is that Also, after evaluating our model, we will do a kind of comparison with minimum expectation. Let's see. Let me write here. Evaluate the model. And the second thing that we will be doing here, is the model comparison. Model comparison with minimum expectation. Now, what does it mean to say? Model comparison with minimum expectation? It means to say that suppose we have trained the model. Fine, we have evaluated the model. Now, one more algorithm, if I want to train, if I want to see that this particular algorithm can give more good result, more good accuracy, like as compared to the previous one. So at that point, we used to set a minimum expectation, comparison with minimum expectation. Suppose let's say I want this new model after training to give accuracy 3% more than what we already have in the production. So at that point of time, if we are going to get fulfilled with this particular minimum expectation that we set, that is to increase the accuracy with 3%. So in that case, what we are going to do is we are going to replace that particular model that we are already set in the production with this new model. So in the model evaluation, two major steps that we used to perform is first is evaluating the model with the trained algorithm. Also, we used to compare the model with minimum expectation. All right. Okay, now the last step in machine learning project pipeline is pushing the model. Push model. Now, pushing the model simply means that if in case all your criteria get fulfilled till this step, it's the time for you to push your model to the production. Now, here it means to say that you can save this particular model in a directory. Also, you can put this final model onto the cloud, such as S3 bucket, Azure Blob storage, as well as Google Cloud Storage. There are several cloud storage where you can push your model, and while predicting, again you can be directly able to predict through this particular stored model. Now, after putting this model onto this storage system or saving this model into a directory, the next step that comes is for prediction, right? Now, how we actually used to perform that, let's understand. If you remember, here we save two pickle files, one in the data transformation step, right? Here we save the pickle file on which we perform the EDA and various kind of transformation techniques or feature engineering. Now again, in this particular step in model training, also we had saved a pickle file, right? Now it's time to utilize these two pickle files. What we will do is we will be taking this pickle file of feature engineering as an object. Also, we will be taking this model training pickle file as an object. See here, guys. We will be taking feature engineering object file, and also we will be taking here model training object file. Okay. So here, if you see, I have two particular pickle object. What we will do is we will combine these two pickle file object and we'll be creating one final pickle file object, that is of feature engineering object and model training object. Now we will save this particular final model somewhere and we will be performing the prediction on top of this final, let me write here, final pickle object. Okay. If we have to do any kind of prediction, so we will be using this final pickle object only to do the prediction. Now how we will be doing the prediction? Let's understand. Here we will be having the incoming data. Okay, here we will be having incoming data. Now in between I'll be having the transform data. Transform data or feature, you can say. And here we will be having the prediction. Here we will be having the prediction. Now for the real-time prediction, we will be using this particular pipeline to predict. And also this pipeline is called as prediction pipeline. Okay, prediction pipeline. Where where we will be having the incoming data. Here we will pass through this final pickle object, and here we will be getting the prediction. So in general, what you understood is this is the final pickle object on which we will be performing the prediction, and this prediction pipeline will look like this, where we will predict like incoming data will come from here. It will pass through final pickle object and will provide us the prediction. So this is it about machine learning project pipeline, how in the industry machine learning project pipeline gets developed, and how data scientist or machine learning engineer used to work on several kind of project at the same point of time. So nowadays, what happens that in the bigger companies such as Facebook or Google, this kind of project pipeline is getting followed. So that's it from my side. If you have any queries, you can ask in the comment section. I'll be happy to answer. That's it from my side, guys. Till then, keep learning and keep exploring from your end. Thank you so much.